This video will cover aspects of maps and mapping techniques. Map projections are mathematical transformations that represent the Earth's curved surface on a flat map. They are essential for cartography, allowing us to visualize and analyze geographic information. While no flat map can perfectly represent the Earth, different projections aim to preserve certain characteristics like shape, area, distance, or direction. Why are map projections necessary? The Earth is a sphere, or more accurately, an ellipsoid, but maps are flat. Transferring a spherical surface to a plane inevitably introduces distortion. Various map projections are designed to minimize distortion in different aspects, making them suitable for different applications. Key aspects of map projections. Projections often involve wrapping the Earth's surface onto geometric surfaces like cylinders, cones, or planes. Three common map projections include cylindrical projections, conic projections, and azimuthal projections. These projections differ in how they project the Earth's curved surface onto a flat plane, and each has its own strengths and weaknesses. Cylindrical projection maps. Imagine a cylinder wrapped around the Earth, and then unwrapped to create a flat map. The prime example of the cylindrical projection map is the Mercator projection map. The strengths of the cylindrical projection map is that it can maintain accurate shapes near the equator. The weaknesses of the cylindrical projection map are that it distorts areas and shapes significantly near the poles. Conic projections. To create a conic projection map, imagine a cone placed over the Earth and then unfolded to create a flat map. The key example of a conic projection map is the Lambert conformal conic projection map. The strengths of the conic projection map are that it is suitable for mapping areas with an east-to-west extent, as they minimize distortion in that direction. The weakness is that distortion increases further away from the cone's apex. Azimuthal projections. To create an azimuthal projection map, create a plane tangent to the Earth at a specific point, and then project the Earth's features onto that plane, like a photograph. A common example of an azimuthal projection map would be orthographic projection maps. The strengths of an azimuthal projection map is that it minimizes distortion of directions and distances from the central point. The weakness is that an azimuthal projection map increases distortion as you move further away from the central point. Map distortion. Every projection distorts at least one of these four main properties of a map: shape, area, distance, and/or direction. Shape distortion. Different map projections can distort the shapes of landmasses. For example, the Mercator projection, while useful for navigation, distorts the shapes of continents, especially at higher latitudes. Area distortion. Some map projections alter the relative sizes of areas on the map. The Mercator projection, again, distorts the area significantly, making Greenland appear much larger than it actually is in relation to other countries. Distance distortion. Distances between points on a map can be inaccurate depending on the projection used. Some projections may exaggerate distances while others may shorten them. Direction distortion. The direction between 2 points on a map may not be accurately represented, especially in certain map projections. For example, the Mercator projection distorts the angles between points, making it difficult to determine true directions between locations. Choosing the right projection. The appropriate map projection depends on the specific purpose of the map. Maps must meet the specific needs of the intended user. Each map must balance required accuracy with the inevitable distortion present in any map. Navigation maps are fundamental tools for navigating physical spaces, whether it's finding directions on a road trip, hiking in the wilderness, or charting a course at sea. Geographic understanding maps help us understand the world by visually representing geographical features, like mountains, rivers, and bodies of water, and their spatial relationships to each other. Planning activities maps are used for planning various activities such as route planning for hikes, setting up campsites, or designing cities and infrastructure. Showing political boundaries maps display the boundaries between countries, states, and other administrative divisions, providing a visual representation of geopolitical divisions. Visualizing specific themes are called thematic maps, also known as special purpose maps. They focus on a specific theme like population density, climate patterns, or agricultural land use, allowing for the visualization of spatial data. In essence, map projections are the tools cartographers use to represent the Earth's complex, curved surface onto a flat map. They must meet the specific needs of the intended user, balancing accuracy and distortion to create a useful map. Thank you for exploring maps and mapping with Mr. Rich's Earth Science class. We look forward to exploring our world with you again sometime.